operations. So remember, those were addition, subtraction, multiplication, and division. Now remember, with our addition and subtraction, we're mostly just combining like terms. With our multiplication, you're either distributing or multiplying out. And then remember, with our division, we're just making a fraction, one on top of the other. Now with the division, most of the time you're not going to simplify it. So I had a couple of questions over the homework that was like, how do I simplify this? If it's division, most of the time you're not going to be simplifying. But what do we have to worry about with our division?
Points that you can't use.
Points that we can't use, and how do we find that?
Don't you set the denominator to 0?
Yep, we set our denominator equal to 0. So you do need to list whatever that restriction is for our denominator. Now, today we're going to go over the last type of operation, which is composition functions. So, remember your composition function, it uses a little symbol that kind of looks like a multiplication symbol, but it has like a hollow middle. And so, it is F composite G, okay, is the same thing as taking F of G. So remember, it's not multiplication. So please do not perform multiplication. We are plugging one function into another function. So the example that I have, okay, is our turducken. So have any of us ever heard of our turducken? Yes? Have any of us ever tried a turducken? Okay, I haven't ever tried it. I mean, it sounds interesting.
Oh, yeah.
But, so basically what a turducken is, if you didn't know, is it is a duck that is stuffed inside of a chicken, which is stuffed inside of a turkey. And then you cook it, and you eat it.
What's the point of that?
It's a lot of meat and fat, and it's good. So, it's not probably the healthiest thing in the world, but I would think it probably tastes fairly good, depending on how it's cut. But the reason why I bring it up is because, so you can kind of think about like your innermost layer, right, which would be our duck, is going to act like our x values. So we're going to plug our x values, so that's what this like first little bubble over here on the right-hand side represents. We're going to take those x values, and we're going to plug them into G, which for our reference is going to be like our chicken. So we have G of x. So you're putting your x's inside of your G. And then you're taking those values and going on, and you're going to put those inside of F, which for our picture would be our big turkey. So I use this reference to help us think about that you are placing one function inside of another function. Okay, it's not multiplication. So that's the most common error that I get, is that people want to try to multiply by an x, or multiply the two functions together, or do other weird things. Okay, so remember that you are plugging a function into another function. Questions on that so far? So let's look at some examples. So, our first example, they give us f of x equals x plus 2 and g of x equals 4 minus x squared. And then it says find the following. So, our first one is f composite g. So, which one am I plugging in? G, because it's the one that's on the right. So, I would have f of g of x. Okay? And they tell us that g of x is 4 minus x squared. So then what do I do with the 4 minus x squared?
Plug it in for x on that.
Yes. So remember, we looked at a couple of examples like this when we first started doing functions. Remember, we are evaluating. Just like we can evaluate at a number, we plug the 2 in, or plug whatever the number is in for all of our x's. Now, even if it's an expression, so it's stuff that has variables in it, we're still plugging it in for anywhere that we have an x. And since my f is what's on the outside, that's the one that we're going to be plugging into. So notice that our f of x has an x to begin with. So instead of writing an x, I'm going to write 4 minus x squared. And then basically I'm going to write the rest of the function, which in this case is just plus 2. So I'm basically replacing my x with whatever's on the inside of my parentheses. And then we just simplify. So we end up with negative x squared plus 6. Questions on that? So remind me, does order matter for our composite functions? Yes. Okay, let's look at why. So this time, if I take G composite F, which one am I plugging in? F. So they tell us that F is x plus 2. So again, where am I plugging in the x plus 2? Into the x squared, yep, for my g of x. So again, if it doesn't have an x, it just stays the same. So the 4 and the minus sign just stays the same. The only thing that I'm replacing is instead of writing an x, I'm going to write an x plus 2. But it still has to be squared. So be careful on this, because a few of us missed a question like this on our concept check. So remember that when we square things that have variables in them, can I distribute my square? No, because we have a plus sign, an addition sign, right? So remember that to square x plus 2 is the same thing as to multiply x plus 2 times x plus 2. So we would have to like FOIL it out. So what do we get if we multiply that all out? X squared plus 4x plus 4. So then I'm just subtracting, so we get negative x squared minus 4x, and then 4 minus 4 gives us 0. So did I get the same thing? So did I get the same thing for f of g that I got for g of f? No. So if the order matters, what does that mean that composite operation is not? So like what operations does the order not matter? Multiplication and division order matters, right? Because if I do the top divided by the bottom and flip that, right, that's a different number. Addition. So both of those have what property? Commutative property, right? So the order, I can flip them, and I get the same thing for addition and multiplication. Now for subtraction, division, and composition function, they are not commutative because the order does matter. Does that make sense? We all okay with that? So then, for part C, basically it asks us now to take what we just got for G composite F, and we're going to plug in a negative 2. So we would have negative 2 squared minus 4 times negative 2. So negative 2 squared gives us a positive 4, but then we still have a negative on the outside. Negative 4 times negative 2 is a positive 8, so we just get 4. So that would be our answer. So we need to be able to take composite functions if they're just left with variables, but we also need to be able to evaluate them at specific numbers as well. Questions on that? Yes? No? Okay. So you're going to try one on your own. So you're going to find F composite G, and then G composite F, okay? And we'll talk about the domain here in a second. We're not going to worry about the range. We'll just talk about the domain. Alright, so it looks like most of us have answers. So remember, again, that this is not multiplication. So I did F composite G first. So I'm going to plug 4A in. So I have 2, because that's what's on the outside, and then instead of writing an A, I'm going to write 4A, and then my minus 5 still stays the same. So I end up with 8A minus 5. And that will be our final answer. So then for our other one, we have G composite F. So this time, we're plugging in F of X, which they tell us is 2A minus 5. So we're going to plug this in for the A that's in our G of X. So I write my 4, and then instead of just putting A, I'm going to put 2A minus 5. So I'm going to distribute, and I get 8A minus 20. So that would be our final answer. Okay. Alright, and then it asks us if there's any domain restrictions. So remember that with our operations, if I have any restrictions for either of my two functions that we're combining, those still have to be restrictions for the end function, okay? But does F or G have any domain restrictions? No, because they're polynomials, okay? Then does my ending function have any type of domain restriction? No. So, do I have any types of domain restrictions for any of those? No. So we could say that our domain is going to be all real numbers. Now, that won't always be the case, okay? So let's look at one together. So this asks us to find the domain of F composite G of X. So, again, remember that since my G comes second, that's what we're plugging in. So I have F of the square root of 9 minus X squared. Now, what am I going to do with my square root of 9 minus x squared? In which one? F. Yes. So I'm replacing my x with the square root of 9 minus x squared. But the squared still has to be on the outside. And then the minus 9 still has to be there. Are we all okay with how we got that? Yeah? So then we just want to simplify if we can. So what is a square root squared? The number on the inside, right? So we would just have 9 minus x squared, because I squared a square root. But then we still have a minus 9. So what are we left with? Almost negative x squared.
Does Kate Weinrich in class?
I do.
Can I have her dismissal, please?
Yes. Okay, so now let's think. This is a parabola, right? So does a parabola have any domain restrictions?
Yeah.
Domain
No.
restrictions. No, we can plug anything into a parabola and that's fine, okay? But remember that we got this by combining our two other functions, right? So if there are things that I can't plug into G, okay, then that means that it's going to keep on going, which means that I'm also not going to be able to plug them into my final answer. Does that make sense? Yes? Remember, like, we had the little circles? I have to start with my x's that we can plug in to G, right? Well, if those x's can't be certain things, then that means that they're not going to make its way down the little bubble chart. Does that make sense? So we have to figure out, for our f and our g, if there's anything that would cause restrictions, or x's that we're not allowed to have. Okay? So, for my f of x, it's just a quadratic. Is there anything we're not allowed to plug into f of x? No, that's fine. What about our g, though? Is there anything we're not allowed to plug into g? Yes, but how do we know what it is? So what do we have that's gonna make us have restrictions? A radical. So what are we not allowed to have with radicals? Negatives where? On the inside. Well, what's on our inside right now? 9 minus x squared. So how do I write mathematically not negative? I mean,
Equal sign with a sign.
we don't want it to be less than, because that would be negative.
Oh,
We want it to be greater than or equal to 0, right? Because that makes that stuff positive. Agreed? Because we're trying to figure out what x can be. Yes? Okay. Now, what type of inequality is this? The quadratic inequality. Okay, so remember we talked about these before. Because if I just add my x squared over, and then we take the square root, we would get plus or minus 3 is greater than or equal to x, which doesn't make sense, right? So remember, this is where we talked about having to do like the 3 steps. We have to find our critical numbers, right? And then we're going to look at our number line so then we can create our intervals. Yes? Okay, so how do I find our critical numbers first? Remember, basically, we want to just solve it, but with what? An equal sign. Yeah, so we want to see where does this function equal 0. So we drop our inequality sign. So we would add x squared, take the square root. So what does x equal? Plus or minus 3. So then, remember that our next step was to look at our intervals. And so remember, that's where we created the number line. And we're going to place each of our numbers that we got from our critical values on our number line. Yes? Okay, and then remember, we just pick numbers that's going to be in each one of those little intervals. So what's something that is going to be in our first interval? -4. Now, if I plug in a -4, what do we get? -4 squared gives us 16. 9 minus 16 gives us almost. No, so what is it? 9 minus 16 gives us -7. Yeah? And remember that it would be -7 is greater than or equal to 0. Is that a true statement? No. So we know that that first interval is not in our answer. So that's something that's in our second interval. So in between -3 and 3. 0. So if we plug that in, 0 squared gives us 0. 9 minus 0 gives us 9. So is 9 is greater than or equal to 0 a true statement? Yeah, so we know that that part in the middle, I'm going to shade it in, because that would be a part of our answer. And then what would be a number that's to the right of 3? 4, and what are we going to get? Well, since it's squared, right, we're going to get the same thing. So it would be -7 is greater than or equal to 0, which we said was a false statement. Okay. So then remember, the last thing we had to look at was at the two numbers, okay? So if I have an equal to bar, right, what type of dot is going to be at -3 and 3? Close, because I can equal those two numbers, okay? So that means that our domain would be what? -3. So 3, right? Because that was the part that we could be. And then what do we need around those? Brackets, because we can equal both of those numbers. Questions on that? So again, remember, if it's a restriction of one of our functions, it's also going to have to be a restriction of our final answer. So you're kind of having to combine the domains of your different functions. Yes? Questions about that? Okay, we have one last type of problem to look at. Alright, so for us, we've been taking two functions and doing the composite and getting an answer. Now basically we're going to work backwards. This time they basically give you the answer and they want to know what two functions, if I composite them together, would give me that. Are y'all with me? So we're kind of trying to work our way backwards. So like we're looking for an F and a G, but if I composite them, I get h of x. So our answer is going to have to consist of like two functions because otherwise I don't have anything to composite. So notice the easiest place to start is if I have any exponents. So like here I have a squared. We all see that in my denominator? So instead of writing x minus 2, I'm just going to write it as an x squared. So then, what would I have to plug into x to get it to be my h of x? X minus 2. So those would be two functions that if I composited them together, I end up with h of x. You okay with that? Can anyone think of another example? So is there another way that I could write it? You could do 1 over x for f of x. So then what would our g of x have to be?
X minus 2 all squared.
Agreed. Are y'all okay with that? So notice, like, if I plug all of this into my x, I end up with 1 divided by x minus 2 squared, which is what we wanted. Now, there are actually two more pretty easy ones. Does that work? If I plug x in for x, do I end up with what we wanted to get? Yeah? Would it work the other way too? So like if this was x and g of x was the whole thing, do we get h of x?
Yeah.
Yeah, because I'm taking my whole fraction and I'm plugging it into x, and so you end up with the same thing. Now, notice that my other two I couldn't flip, right? Like if I were to swap these for like this second one, I would have 1 divided by x minus 2 quantity squared, right? That doesn't work. So usually the only time that you're going to be able to write it either way is if one of them is just an x. Does that make sense? So on like a test, I would probably ask you for at least 3 answers. Because if you wrote both of these, okay, I would want at least one where we did a little bit of critical thinking. Does that make sense? Okay, so we have 2 last examples. So I want you to work on these in your group and come up with at least 2 ways to find these functions.
I don't know. This one. I don't think you can flip this one. You can't flip this one. One of these you can't flip this one. Backwards. Not these two, but not this one. It's actually by itself.
Alright, so it looks like most of us at least have a couple answers. So for our first one, we could have x cubed, and then g of x would need to be 1 minus x. And then remember that we could also do where f of x is just the whole thing, and g of x is just x. Okay? If you wanted to like play around with like negative exponents or like things like that, you can also do it that way. But those would probably just be like the most straightforward way to do it. Okay. For our second one, if I wanted to do 2, the first one, we could do 4 divided by x squared. And then our g of x would need to be x plus 2. But then we could also do 4 divided by x, and our g of x could be 5x plus 2 squared. And again, you could do one of them being just an x as well, but like I said, those 2 are going to be the most straightforward ones. Okay, so questions on any of that? I would make sure that we know how to do these types of problems. There are a couple of these on your homework assignment, because there probably, hint, probably will be one like this on your test. So I would make sure that we know how to do one. Thursday.